In this video, I am going to introduce you a new topic called solid state. As you already know, matter can exist in three states: solid, liquid, and gaseous. Those can be distinguished between with some properties like, let's say, motion of particles. Then we know that gaseous molecules are continuously in random motion. The liquid particles are in motion but comparatively less than in case of gases, and in case of solids the particles are kind of fixed and they can only vibrate in their position. In terms of intermolecular force of attraction, we know that solids have highest intermolecular force of attraction and gases have least force of attraction. In terms of interparticle separation, we can say that in case of gases it is the highest and in case of solids it is the least. Solids have fixed volume and fixed shape. Liquids have fixed volume but different shapes, and it depends on the container. And in case of gases, the volume and shape both depends on the container. Solids are least compressible and gases are most compressible. Now, solids can be classified into four parts depending on the constituent particles. So one is molecular solids, where constituent particles are molecules. Metallic solids, in which the constituent particles are atoms. Network or covalent solids, wherein constituent particles are atoms but you will have continuous networks of atoms. Ionic solids, where the constituent particles are ions. Now, in case of molecular solids, we can further classify them in terms of the bonding or attractive forces that are existing between the molecules. So there are three cases. One is dispersion type of force of attraction, which normally happens in case of atoms or molecules which are non-polar in nature, for example argon. And the second one is dipole-dipole interaction, which happens between polar molecules like HCl. And the third one is hydrogen bonding, which happens in case of molecules like H2O. Now, in terms of physical nature, the first type of solids are going to be soft. The second one are also soft, for example HCl solid. And ice, as you know, is hard in terms of physical nature. These are the indicative melting points. So these are important only in terms of just to get an understanding of what are the ranges of melting point and what are the indicative physical state of each type of solids. You don't actually have to memorize these values. Also, in terms of electrical nature, the molecular solids are going to be insulator. The metallic solids like silver, copper, magnesium are conductor, and network solids like SiO2, SiC, which is silica and silicon carbide, diamond or graphite, are insulator. And ionic solids like NaCl, MgO, KCl, etc. are insulator in their pure form, but they are conductor in their ionic solution or in terms of melted solids. The second way in which solids can be classified is crystalline and amorphous solid. I think most of you must have heard about this type of solids. The crystalline solids are, for example, silver, iron, copper, NaCl, H2, etc. And amorphous solids are like glass, plastics, or amorphous silica. The main difference is the constituent particles in case of crystalline solids have a particular arrangement of atoms, and in case of amorphous solids the particles or the constituent atoms or molecules are randomly arranged. Crystalline solids can be prepared if you cool the liquid slowly and in controlled condition, and amorphous solids are normally prepared by cooling the liquid very fastly. The structure of the crystals in case of crystalline solids depends on how you actually cool the substance, and you can actually get different type of crystals depending on the cooling method, and different types of crystal structure of the same substance are called polymorphs of each other. The another difference in case of crystalline and amorphous substances is that crystalline substances have a fixed value of melting point. So if you look at this graph, over here this is liquid phase. If you start dropping the temperature, at this particular temperature the freezing process starts and conversion from liquid to solid starts. The temperature remains constant as long as the entire liquid is getting converted into solid. Once that is done, then only the temperature will drop. So in this case we are saying that the melting temperature is a fixed value, which is not the case in case of amorphous substance. So if you look at this graph, the liquid phase exists up to this point. At this temperature the process of freezing takes place. Liquid and solid coexist during this particular area, but the temperature keeps on changing, and once the entire liquid is converted into solid, then again the temperature drops. So in this case we are saying that there is a range of temperature in which this melting takes place. There is no particular melting point in case of amorphous substances. The fourth important difference between the two is that we call crystalline substances to be anisotropic, which means that physical properties like mechanical strength, refractive index or electrical conductance have different values in case of different directions. One of the example you can think about is graphite. So in case of graphite, the current can pass through in case of within the same plane, the horizontal plane you can say, and current actually does not pass if you pass the current in the perpendicular direction. And in case of amorphous substances, we call them isotropic, which means that the value of the physical properties is same in all the directions. This is because the atoms are arranged in random fashion, so the properties are actually same in all the directions.